Good day, viewers. My name is Ode Godwin Daniel, and I'm your tutor for today. Please do well to subscribe and follow us across all social media pages at Gordon School of Mathematics. In today's class, we'll be looking at the topic simple equation. So what is an equation? An equation is a mathematical statement that contains two expressions, that is, two mathematical expressions on both sides of the equal to symbol. So, for example, I have 3x plus 5 equal 2x minus 3, right? If you look at the equal to symbol, we have a mathematical statement on the left-hand side of the equal to symbol, and we have another mathematical statement on the right-hand side of the equal to symbol. Now, the mathematical statement on the left-hand side and the right-hand side is called an expression. Right? So what is an expression? An expression is also a mathematical statement that contains one or more mathematical terms joined together by a mathematical operator. So from that definition, we look at what an operator is, and we also look at what is a term. Now, an operator in mathematics is any symbol that indicates an operation to be carried out. For example, we have the positive symbol that indicates that an addition is to be carried out, right? We have the negative symbol that indicates that a subtraction is to be carried out. We have the product symbol that indicates that a multiplication is to be carried out. We also have the division symbol that indicates a division is to be carried out. We have the exponential symbol that indicates that an exponent is to be carried out. We have the root symbol that indicates that a root is to be carried out, right? So, and so on and so forth. An operator is any mathematical symbol, any symbol in mathematics that indicates an operation is to be carried out. Then what is a term? A term is either a single number that is a constant. A constant is a number that is not attached to any variable, or a single variable. A variable in mathematics is a letter or a symbol that represents an unknown. So when we are looking for an unknown number or an unknown quantity, we invoke or we use a variable. So, and that variable in mathematics is a symbol, or most often a letter of the English alphabet that represents an unknown number or an unknown quantity. So now, a term is either a constant or a variable, or the multiplication of a variable and a constant. So we have a term can either be a constant, say 3 for example. So 3 is a term in mathematics, right? And then we have also x, which is the most common variable in mathematics, but not the only variable. Any letter of the English alphabet can be a variable, right? So x is also a term in mathematics, right? The combination of a constant and a variable, say 4y for example, is also a term. So these are terms, these are operators. So an expression is a mathematical statement that contains either one of these or no. It could be 2, it could be 3, it could be more, right? Then that are joined together with or by any of these operators. But then an expression, the difference between an expression and an equation is that an expression does not have the equal to symbol. So an expression is a mathematical statement that contains a term, any of these or more of these terms that are joined together by any of these operators. Just as we have on the left hand side, we have 3x is a term, plus is an operator, and we have 5, another term. So 3x plus 5 is an expression that is made up of two terms. The first term, 3x. The second term, 5. And the operator between both of them is plus. Now, on the right-hand side, we have 2x minus 3, right? So 2x minus 3 as an expression is made up of two mathematical terms, 2x as a term and then 3 as another term, joined together by this operator minus. Now, when we have two expressions and we introduce the equal to symbol, it's these two expressions ceases to be an expression and become an equation. So an equation is a mathematical statement that contains two expressions on both sides, that is the left hand side of the equal to symbol and also the right hand side of the equal to symbol. All right, so balancing an equation. It is important to note that an equation remains balanced if the left hand side is equal to the right hand side. Now, if I have 3x plus 5 equal 2x minus 3, for example, we have an expression on the left hand side, we have an expression on the right hand side. Now, take for example, if I'm to subtract 5 from the left hand side, so that I want to take away 5 from this left hand side, I have 3x plus 5 minus 5 equal 2x minus 3, right? Now, if you look at this singular act of subtracting 5 from the left hand side had made this equation to be imbalanced. Why? Because I had carried out an operation on the left hand side which is not carried out on the right hand side. So an equation is only said to be balanced if what is done to the left hand side is also done to the right hand side. That is, whatever I do to a particular term on the left hand side must be done to all the other terms, both on the left hand side and on the right hand side. So for example, right, I have 3x plus 5 on the left hand side, and I had carried out an operation to subtract 5 on the left hand side. That 5 I subtracted on the left hand side must be subtracted on the right hand side to make this equation balance. Now, if I subtract 5 from the left hand side and subtract 5 on the right hand side, and then my equation is correct. It is balanced. Right? So if I go ahead with this, I'll have plus 5 minus 5 is 0. So I'll have 3x left on the left hand side equal 2x minus 3 minus 5 is equal to minus 8. So this equation is balanced because it is a resultant from an operation that was done on the left hand side as well as on the right hand side. That is to say that an equation is only balanced when what is done on a side is also done on the other side. Now, take for example, I want to take away 2 from this right hand side. I don't want 2 to be on the right hand, 2x to be on the right hand side. So what do? This is plus 2x, so I subtract 2x from the right hand side to give me 0 here. Now, if I have 3x equal 2x, I've subtracted 2x now, minus 8 on the right hand side. This equation is not balanced yet. Why? Because I have subtracted 2x on the right hand side, but I have not subtracted 2x on the left hand side. So for this equation to be balanced, I must also subtract 2x on the left hand side. So this will now become 0. I will have 3x minus 2x give me 1x, which is x, equal what? Minus 8. We've been able to find the solution for x in this equation, right? Now, let's check if this equation is balanced by substituting the value for the unknown variable x in both expressions on the left hand side and on the right hand side. Now, we have 3x plus 5 on the left hand side equal 2x minus 3 on the right hand side, where x is equal to minus 8. So we have 3 is multiplying minus 8, then plus 5, equal to multiply minus 8, then minus 3, right? 3 times minus 8 will give us minus 24 plus 5 equal 2 times minus 8 will give us minus 16 minus 3. Okay, so minus 24 plus 5 will give us minus 19. That is, you have a debt of 24, you have 5, so if you pay 5 from your debt, you have 19 debt left. Equal minus 16 minus 3 is minus what? 19. So this equation is balanced, plus everything I did on the left hand side and on the right hand side, right? As long as what I did on a side is also done on the second side, the equation remains balanced. But when I just perform and carry out an operation on one side alone, the equation becomes imbalanced. Let's take for example, when I subtracted 5 from the left hand side, I did not subtract 5 on the right hand side. So we now have 3x equal 2x minus 3, right? So now, let me also subtract 2x on the right hand side and not subtract 2x on the left hand side. What will I have? I will have 3x equal 2x minus 2x minus 3, right? So this 2x cancels, becomes 0. So we have 3x equal minus 3. Now to take away 3 from x, I divide both sides by 3, and then x is equal to minus 1. Now let us check if this imbalance, remember what I did is not balanced, because on the left hand side I only subtracted 5 on the left hand side, but I did not subtract 5 on the right hand side. I subtracted 2x on the right hand side, but I did not subtract 2x on the left hand side. So what did I get? I got x equal to minus 1. Now we want to confirm if the equation is balanced or not. Now, how do we do that? We subtract the value of the unknown variable x that we got into the equation, right? So that we will have we have 3x plus 5 equal 2x minus 3, and then we got x equal to minus 1, right? So we have 3 multiplying minus 1 plus 5 equal 2 multiply minus 1 minus 3. 3 times minus 1 is minus 3 plus 5 equal 2 times minus 1 is minus 2 minus 3. Now minus 3 plus 5 will give us 2 equal minus 2 minus 3 will give us minus 5. If you look at it, you realize that the equation is not balanced, because we can't use this equal to, because 2 is actually greater than minus 5. It becomes inequality, not equation, right? If it must be an equation, the left hand side must be the same as the right hand side. That goes to say that an equation remains balanced if what is done on the left hand side is also done to the right hand side. So next, we look at solving a simple equation, and the first solution we want to find is solving a simple equation involving collection of like times. What does like times mean? It means the collection of variables on one side. Most often we use the left hand side, but it is not restricted to the left hand side. It could also mean the right hand side, since both are the same. After all, left hand side is the same thing as what? Right hand side. So the variable can be at the left hand side, it can also be at the right hand side. So when we say collection of like times, it simply means combining variables on one side and then combining constants on the other side, right? So for example, we have 3x minus 2 equals 7. Now to solve this equation by collection of like times, it simply means that we eliminate the constant that is with the variable, right? If you look at this expression on the left hand side, we have a variable and then we have a constant, right? And then if you look at the expression on the right hand side, we have a constant. So we have to delete the constant on the left hand side. Now to delete the constant on the left hand side, we find the inverse of the constant. What does inverse mean? Inverse means the opposite symbol of that constant. For example, what we have is minus 2. The opposite of minus 2 is what? Plus 2. So just to delete minus 2 from this left hand side, we use the inverse of minus 2, which is the opposite of minus 2, and that is plus 2. So that means we have 3x minus 2 plus 2, right? But then remember that whatever you do to a side must be done to the other side. So because we have added 2 to the left hand side, we must also what? Add 2 to the right hand side. So this will give us 3x, because minus 2 plus 2 is 0, and then we have 7 plus 2, we have 9. Now also, if you look at the left hand side, we have 3x, right? But what we are looking for is x, not 3 multiplying x. What do we then do to have x alone? We also find the inverse of 3x, the inverse of 3, right? Of multiplication rather. The inverse of multiplication is division. So since we have 3x, 3 multiplying x, to have x alone, we divide 3x by what? 3. Always remember, whatever you do to a side, you must do what? To the other side. So 3 we cancel 3, and then we have x on the left hand side. So 3 here 1, 3 here 3, so that our x is equal to what? 3. Now we have the value for our what? Unknown variable, which is x. Now to confirm whether we are right or wrong, we check by imputing the value of the unknown variable into the equation. So we check. We have 3x minus 2 on the left hand side, and we have equals 7 on the right hand side. We have x equal to what? 3. So 3x means 3 multiplying 3 minus 2 equal what? 7. 3 multiplied 3 is 9 minus 2, we have equal what? 7. 9 minus 2 is 7, equal what? 7. And this is absolutely what? Correct. Another example that we'll be considering is 4x minus 5 equal minus 3 minus 2x. Now what we want to do is to have all unknown variables on one side, preferably the left hand side, and all constants to the right hand side. So if you look at the left hand side, we only want variable to be there. So but there is a variable and there is a constant. So we want to delete this this constant that is on the left hand side from this left hand side. Now for us to delete this constant, what do? We use the inverse of the constant, which is, the constant is what? Minus 5. The inverse of minus 5 is the opposite of minus 5, which is plus 5. So what do? We add 5 to the left hand side. But remember, we can't just add 5 to the left hand side, we must also add 5 to the right hand side. So we have 4x minus 5 plus 5 equal minus 3. Now, the 5 I'm adding to the right hand side, I will add it, because it is a constant, I will also add it to a constant like itself. So we have plus 5, then minus 2x. Okay, so this will then cancel this. We have 4x equal minus 3 plus 5 will give me 2. Then we have minus 2x. Now, remember that all variables have to be on the left hand side, not on the right hand side. So it means that we have to delete this variable that is on the right hand side. And how do you delete? Remember, every time you want to delete, you find the inverse of that what? Number. So we want to delete minus 2x. The inverse of minus 2x will be what? Plus 2x. Which means that I have to add 2x on the right hand side. But always remember, you must also add 2x on the left hand side. That is what makes the equation balance. So we have 4x, I'm adding 2x now, equal 2 minus 2x plus 2x. Now, this will make this to be 0 on the right hand side. 4x plus 2x will give me 6x equal 2 on the right hand side. Now, remember that the end point of an equation is to find the value of the unknown, which is x. The unknown here is x, not 6x. Now, if you look at this, 6 is multiplying x. So to delete 6, we use the inverse of multiplication, which is what? Division. So we are dividing 6x by 6. But then, remember, it must also happen to the right hand side. So 6 will cancel 6. We have x left equal 2 here 1, and then we have 3, which is 1 over 3. Now let's check. The equation is, on the left hand side we have 4x minus 5, equal on the right hand side we have minus 3 minus 2x, right? So we have x equal 1 over 3, we have 4 multiplying 1 over 3 minus 5 equal minus 3 minus 2 multiplying 1 over 3, right? 4 times 1, this gives me 4 over 3 minus 5 equal minus 3 minus 2 times 1, 2 over what? 3. LCM on the left hand side is 3. We have 3 through 3, 1. 1 times 4, 4. Minus, this is over 1. 1 through 3 is 3. 3 times 5 is 15, which is equal, on the right hand side, LCM is also what? 3. This is over 1. 1 through 3 is 3. 3 times minus 3 gives us minus 9. Minus 3 through 3 is 1. 1 times 2, 2. So this gives us 4 minus 15 on the left hand side is minus 11 over 3, which is equal, minus 9 minus 2 is also minus 11 over 3. So we are absolutely correct. So finally, before we end the class today, we're also going to be looking at solving simple equations involving fractions, right? So the first thing to do when you want to solve equations involving fractions is that you multiply all the terms by their LCM. So first, find the LCM of all the terms, then multiply all of them by the LCM. The next thing is you now do is you collect like terms, then you solve the equations just the way we would solve equations collecting like terms. Okay, so we have an example here. We have x minus 15 as the numerator over 4 minus 2 equal 5. All right, of course, you know that the denominator of every other term is 1. So the LCM is equal what? 4. Now, having found the LCM, the next thing you will do is to multiply all terms by 4. So x minus 15 over 4 is a term, 2 is a term, 5 is a term. So what do? We have x minus 15 over 4 times the LCM, which is 4, then minus 2 times the LCM, which is 4, equal 5 times the LCM, which is 4. So by this cancels this, we have x minus 15 minus 2 times 4, 8, equal 5 times 4, 20. Now, we have x minus 15 minus 8 is minus 23 equal 20. If you look at this, we have a variable and a constant on the left hand side, and then we have a constant on the right hand side. We want to ensure that we have only variable on the left hand side. So we have to delete this 23, minus 23, right? And for us to delete minus 23, we have to find the inverse of minus 23, which is the opposite of minus 23. And that is what? Plus 23. So that gives us x minus 23 plus what? 23 equal. Now, remember, since we have added 23 on the left hand side, we must also add 23 on the right hand side. So we have x, this we cancel this, equal 20 plus 23, 43. And that is our answer. Now, always remember to check, right? On the left hand side, we have x minus 15 over 4 minus 2 on the left hand side equal what? 5. All right, so where x is 43, it means 43 minus 15 over 4 minus 2 equal what? 5. So what do we do? So for the left hand side, LCM equal what? 4. So we have 4. 4 through 4 is 1. We have 1 times 43 minus 15 remains 43 minus 15. 1 through 4 is 4. 4 times 2, we have minus 8. Then we have, on the right hand side, we have 5. 43 minus 15 is 28. 28 minus 8 is 20. So we have 20 over 4 on the left hand side equal 5. 4 through here 1. 4 through 20 is 5. So we have 5 equal 5. So we are absolutely correct. Another example, on the left hand side we have x over 4 plus 3 over 5 equal, on the right hand side we have x over 2 minus 2 over 5. The first thing to do is to find the LCM of all the terms. So we have 4, we have 5, we have 2, and then we have 5. So we find their LCM. 2 first, we have 2, 5, 1, 5. Then 2, we have 1, 5, 1, 5. And then 5, we have 1, 1, 1, 1. So LCM is equal 2 times 2, 4, 4 times 5, 20. The next thing is to multiply all the terms by the LCM, which is 20. Remember, as long as what I'm doing to the left hand side is what I'm doing to the right hand side, my equation is still balanced. So we have x over 4 times the LCM, which is 20, plus 3 over 5 times the LCM, which is 20, equal x over 2 times the LCM, which is 20, minus 2 over 5 times the LCM, which is 20. So we begin to divide through. 4 goes through 25. X times 5, we have 5x. Plus 5 goes through 24. Right? So we have 3 times 4, we have 12 left, equal. 2 goes through 20, 10. X times 10, we have 10x. Minus 5 goes through 24. 2 times 4, we have 8. Now, we have a simple equation now. So, every time we have this kind of equation, we want to have the unknown variables on the left-hand side and constants on the right-hand side. So, let's start with the left-hand side. So, we have a constant 12 on the left-hand side, which is not supposed to be there, so we delete it. Now, to delete this plus 12, we use the inverse of plus 12, which is the opposite of plus 12. And the opposite of plus 12 is what? Minus 12. So that goes 5x plus 12 minus 12. But then, if I've subtracted 12 from the left-hand side, I must also subtract 12 on the right-hand side. So I have 10x minus 8 minus 12. Right? So we have 5x. This, we cancel this, equal 10x minus 8 minus 12 gives me minus 20. Now, if you look at the right-hand side, we still have unknown variable on the right-hand side, which is not supposed to be there. So what do? We delete it. And how do we delete it? We use the inverse of 10 of plus 10x, which is what? Minus 10x. So what do? We subtract 10x on the right-hand side, which we must also subtract on the right-hand side. So now we have 5x equal, 5x, we are subtracting 10x, equal 10x minus 10x minus 20. 5x minus 10x gives me minus 5x, which is equal 10x minus 10x gives me 0 minus 20. At this point, what do? We divide through. We have minus 5 is what is multiplying x, right? But what we are looking for is only x. So what do? We delete minus 5 by using the inverse of multiplication, which is division. So we are dividing minus 5x by what? Minus 5, right? But then we must also divide by minus 5 on the right-hand side. So minus cancels minus, 5 cancels 5, we have x left. Minus cancel minus, 5 here 1, 5 through 20, we have 4. So our x is equal what? 4. Always check. Okay, now, to check, we have x over 4 plus 3 over 5 on the left-hand side equal x over 2 minus 2 over 5 on the right-hand side. Our x is what? 4. So we have 4 over 4 plus 3 over 5 on the left-hand side equal 4 over 2 minus 2 over 5 on the what? Right-hand side. Let's go ahead and find LCM. The LCM on the left-hand side is 20. 4 through 20 is 5. 5 times 4, 20. Plus 5 through 20 is 4. 4 times 3, 12. Equals on the right hand side, LCM here is 10. 2 through 10 is 5. 5 times 4, 20. 5 through 10 is 2. 2 times 2, 4. So what do we have? On the left hand side, 20 plus 12 is 32 over 20, which is equal 20 minus 4 is 16 over 10. Now, 2 through 32 is 16. 2 through 20 is 10. We already have 16 over 10 on the left hand side. and we have 16/10 on the right hand side. That means we are absolutely correct. Thank you for joining the class today. Please do well to subscribe, like, share. If you have any question, drop it for me in the comment section and I'll be more than willing to respond to you ASAP. See you in the next class. Don't forget, Gordon Maths Quest holds this Saturday. Join so that you can win 5,000 naira if you are among the first 2 people to answer the questions correctly. I'll see you on YouTube live on Saturday, and I'll see you in the next class. Thank you.